Yes, ladies and gentlemen, my name is Jonai Emmanuel, and I would like to welcome you to my audio book. And in this book, this section particularly, we shall be discussing chemicals of life. We shall be introducing the definitions. We shall be giving the two groups of chemicals of life, and then also we will be focusing majorly on the inorganic chemicals of life, particularly water and mineral ions. So you're welcome. We want to ask you to subscribe and share this information with other students. So let's get started. So what are the chemicals of life? So basically you realize that chemicals of life are compounds that are needed to maintain life of living organisms. You could imagine so many of them now. These compounds and chemicals that are involved in maintenance of life are collectively called chemicals of life. They are majorly divided into two groups. We have the inorganic chemicals of life and then the organic chemicals of life. Let's start with the inorganic. The inorganic include the mineral ions, some acids, vitamins, water. Those are the inorganic chemicals of life. Then the organic is where we have the complex molecules, the proteins, the lipids, nucleic acids, and carbohydrates. And in this section, we'll be trying to expound more on the inorganic chemicals of life in this particular lesson. So the inorganic chemicals of life, we said one of them is water. Maybe we could start with water. And as you all know, water is said to be life. People say water is life. And maybe that's true. Maybe we could go into details to find out what exactly that statement means. And from our analysis, we realize that about 60 to 70% of our bodies are actually made up of water. And when you narrow down to your body cells, you realize that actually about 80% of the body cell is actually fluid, is actually water. So that means water is quite important in our body. And then we also realize that water is formed from two hydrogen atoms combined with one oxygen atom in the process of sharing electrons. You remember this in your chemistry. And when that happens, a certain shape of a molecule is formed. And maybe if you want to go into details, you realize that that shape is actually triangular in nature. And the angle between the nuclei of the atoms is about 104 degrees. But what's also important to note is that the water molecules form weak hydrogen bonds with other molecules in their neighborhood or the neighboring molecules, and this gives water quite unique properties, as we shall look at. So when you look at the structure of water, you realize majorly which ions are found in the structure of water. Which atoms do we find? We have oxygen, one oxygen atom, and then the two hydrogen atoms. Of course, they bond. Those two hydrogen atoms all bond to one oxygen atom by a mode of bonding that involves sharing of electrons. So let's look at the properties of water. There are quite many, and I know you already know some of them. I'm just trying to remind you that the following are the common properties of water. We're going to look at basically both physical and chemical for now. We're going to look at them concurrently. The first one is that water is liquid at room temperature. So basically at room temperature you expect water to be liquid, but of course change of temperature either above or below room temperature may change the state of water. It may change its physical state. It can easily become gas. If you increase the temperature, it will evaporate and turn into gas, or it can change into solid if you reduce the temperature. But at room temperature, water is expected to be liquid. So that's a good property that you of course know already. We also learned that water has low viscosity. Yes, it has low viscosity, and this is because of the weak hydrogen bonds that we talked about between the water molecules. And these hydrogen bonds, because of their weakness, always break easily, and that makes water to easily flow. Yeah, being less viscous means ability to easily flow. So because of that, the water molecules slide over each other, and flowing is much easier with minimum friction. If you compare water with the honey, you realize water is less viscous compared to a liquid like honey. The other one is water has a high heat capacity. Yes, and this means that much energy is used to raise its temperature because it's used to break hydrogen bonds with which restrict the mobility of the molecules. So we already have the existing hydrogen bonds, and for you to raise the temperature means you must break those hydrogen bonds. compounds fast, and some energy is required. And as a result, water is relatively slow to heat up or even to cool down. So that means water resists change in temperature over a wide range of temperatures, and that's what we call high heat capacity. It has the ability to stay at the same temperature over a wide change of temperature. So I think if you compared water with other materials, you realize water has a relatively high heat capacity, and we shall later on look at the significance of that exactly. How is it important, especially to living things? We will expound on that a little bit later. The other one is that water, of course, is the most important inorganic compound in life, and also the most abundant in the living organisms. Let me ask, what happens when you put a bottle of soda into a deep freezer and that soda happens to turn into ice? What would happen? Well, you guessed it right. The bottle will actually break. Why? It's because the liquid water, when it turns into solid, it expands. So water expands on freezing. And this is unlike other liquids. Some liquids actually do not expand on freezing. Others get compressed when they freeze. But water particularly expands on freezing. And that's a very unique property of water. Wow, that's great. The other one is at 4 degrees centigrade is when water is expected to have the highest or the maximum density, at about 4 degrees centigrade or Celsius. What happens below 4 degrees Celsius and above 4 degrees Celsius, the weight or the density of water reduces. So that's unique as well, and that's why ice actually floats on top of liquid water. Interesting. And then, have you seen in most cases small insects walking on top of water? Yes, you could have seen insects walking on top of water without sinking. How do you call that? Well, that's surface tension. So water has high surface tension, and this is actually the force that causes the surface of the liquid to contract so that it occupies the least possible area or space. And it's the fact that the molecules are oriented so that most hydrogen bonds point inwards towards the water molecules. So that's what makes that layer, that sheet of layer on top of water, that actually can sustain certain weight up to a given threshold for some small organisms even to walk on top. And that's great. That's good. Then we have water actually has high latent heat of fusion. And what does that mean? It means how long do you take, for example, for water in your fridge to turn into ice? You might have to freeze it for a little bit more hours for it to change from liquid to ice or from liquid to solid. So what does that mean? It means much heat must be removed before freezing can occur. So that means water has very high latent heat of fusion. It requires much of the heat to be removed from the water if it is to freeze. So that's what we call latent heat of what? Fusion. So it does not easily freeze. And then when you wake up in the morning and you look at the plant leaves early morning, you realize in most cases they have droplets of water. How do you call that? Well, why are the droplets formed? It means the water molecules come together, come closer. That force is called cohesion. So we could say that water molecules or water actually has high cohesive forces that makes the droplets form. Even rain actually falls in the form of droplets. It means water molecules have the capacity to adhere to each other and move in unison as a drop. So that is what we call cohesion. So water actually has high cohesion forces, but also it has relatively high adhesion force. The adhesion force is the force that enables the water molecules to stick into other surfaces. For example, we talked about the leaves of trees or plants, droplets forming on the leaf. It means the water molecules are adhering onto the surface of the leaf, and that's what we call adhesion. And when you look at most of the wet surfaces, it's because of the adhesive forces. Water can stick onto surfaces of other molecules or other compounds or other surfaces. So we could summarize and say water has both high adhesive and high cohesive forces or properties, which prevents it from breaking even under tension. And then of course we all know that water is colorless and also transparent. In fact, if you get water which is colored, then it's not pure water. Probably it's contaminated or otherwise, but it's expected to be colorless. And then water is believed to be a universal solvent because it dissolves almost everything to some extent. So it can dissolve a wide range of materials, compounds, substances, at least to some extent. So it's called a universal solvent. So if you are looking at solvents, water becomes your first option. So having looked at the properties of water, what are the functions of water now? What do you think are the functions of water, especially to living organisms? In this case, particularly, we are focusing on the functions of water to living organisms. In living organisms, we are talking about the 5 kingdoms of living things: kingdom Monera, kingdom Protoctista, kingdom Fungi, Plantae, and Animalia. So, under what circumstance do these organisms benefit from water? That's what we are going to look at, the functions of water. And we could start by saying that it's a component of cells. Yes, when you look at your plant cell or animal cell, you realize a huge bulk of the cell is actually made up of water. And then it's also a solvent, like we said earlier, and therefore it's a transport medium, or a medium for transport for a wide variety of substances which dissolve in it. And then you also realize that it's a reagent for hydrolysis. For example, the breakdown of starch to produce glucose, that process there, that reaction involves use of water to facilitate the reaction. So it's a great reagent in the different reactions in the bodies of different organisms. Water enables fertilization, especially by the swimming gametes, including the human sperm or sperms of organisms that swim. So they require a fluid medium which is largely made up of water to enable them to facilitate these sperms to reach the ovum for fertilization to occur. Very important process. Then we have, it enables dispersal of seeds, fruits, and even gametes. Gametes like in the lower plants, like the mosses. Actually, fertilization cannot occur without water. Great. Then we have important in transpiration of plants and also important in translocation as well. Water enables germination to proceed, especially by activating enzymes, by transporting hydrolyzed stored food, but also in the swelling and the breaking of the testa in that process of germination. Water is very key, as you've heard. It's also involved in osmoregulation in animals. You must have heard the terms like hypertonic, hypotonic, and isotonic solutions. These are all water factors, as you may realize. It enables cooling, especially by evaporation. What happens when you sweat? After sweating, you actually feel cool. Yes, it means a lot of heat has evaporated with sweat, with water actually from your body, and therefore allows cooling to occur in the sweating, and also panting for other organisms like dogs that pant. And then it's a component of lubricants, especially in the joints, e.g. you remember the synovial fluid is largely fluid and made up of mostly water. I hope you must have seen the earthworm moving. The skeleton it employs is called the hydrostatic skeleton, and that support in that hydrostatic skeleton is derived from water. So water plays a role in the support of hydrostatic systems in organisms. And what happens when something falls into your eyes? You actually release tears, yes, to wash out the foreign body. And the tears are actually largely fluid, largely water, made up of water. And we could say it offers protection as a component of tears, but even mucus. So water plays a big role in protecting the body, especially those soft surfaces. And it also enables migration to occur, especially for the aquatic organisms. So therefore, having looked at the functions of water and also the properties of water, maybe we can now be a little bit convinced that water is actually life. Thank you. See you in the next lesson.